Hi, this is Vasvi from At Home with a new topic, surface area of combination of solids. Okay, so first let me tell you what is the surface area. It is the area any solid would occupy from outside. Let's do that with few examples. Here the first problem says a cubical block of side 7 centimeters is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So here's the cube. You have a cubical block and on top of it a hemisphere is surmounted, right? Now you can just see that the side, they have given you that the side is 7 centimeters, right? So the length, the width and the height of a cube are the same, right? So here it is 7 centimeters and here it is 7 centimeters. All these are 7 centimeters. So naturally on top the length of the side would be 7 centimeters. Since the hemisphere is surmounted on it, it is occupying the maximum size, right? So the diameter of the hemisphere should be 7 centimeter. Okay, that is the maximum it can have. So the answer for the first question is the diameter of the hemisphere is equal to the side of the cube, which is 7 centimeters. Understood? Therefore, the radius would be, radius we can denote it by r. R is equal to 7 over 2 centimeters. The half of the diameter, right? Okay. Now they've asked you to find the surface area of the solid. So how do we find the surface area of the solid? I told you the surface area is the area occupied by the solid from outside. Okay. What all portions you see from outside, you have to find the area of all that. Okay. So total surface area of the solid will be equal to, see, you will have to first find the TSA of the cube, right? So first I would find the TSA of the cube. To this you would add the curved surface area. For sphere we don't say TSA, you call it curved surface area. Okay, you don't take the TSA, only this outside portion you have to take. So that will be curved surface area of hemisphere. Okay, so when you do the curved surface area, you would get this portion also, okay, the outside portion. But actually we needn't take the whole of the total surfaces of this cube, right? Because on top, since this hemisphere is surmounted, this portion, this circular portion of the cube, we needn't calculate. Okay, so you have to subtract this circular portion from this total. Okay, minus base area of hemisphere. So now let me use the formula. So the TSA of the cube, you know, it is a square. You have 6 surfaces, so each surface is a square, right? So the surface area of the cube is 6a square plus the curved surface area of a hemisphere. For the full sphere, the curved surface area is 4 pi r square. Since this is hemisphere, you have to just take half of 4 pi r square. Okay, and then you have to take away the base of the hemisphere. The base of the hemisphere is a circle, so that area pi r square you have to take away. Okay, 6a square plus 2 pi r square, take away pi r square, right? So that means it is 6a square plus 2 pi r square minus pi r square is pi r square. Okay, just find the answer for it. So let me substitute the value. 6 times a is the side, okay, 7 square plus pi, let us take it as 22 over 7, and r, just now I told you the r is 7 by 2 centimeters, right? So 7 over 2 times 7 over 2. Okay? Do the calculation. Your 7 and 7 will go here. This becomes 11 and this. And when you do the calculation, you get 294. Okay, that is 6 times 49 is 294. Add 11 times 7 is 77 divided by 2. So that will give you 38.5. Okay. So you get that is equal to, this is the TSA, okay, total surface area. Therefore, TSA of the solid equals, when you add up these two, you get 332.5. And since it is TSA, right, the area, so it has to be square units. So here the unit is centimeters. So you can write square centimeters. Got it? And this is your answer. Okay, in this second problem, they say a medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its end. Okay. The length of the entire capsule is given as 14 millimeter and the diameter of the capsule is 5 millimeter. You are to find out its surface area. Okay. So imagine this is the capsule and you find that till here it is cylindrical in shape, and onto the both ends you have the hemispheres attached, right? And they say the total length is given as 14 centimeters. Okay. This total length of the capsule is 14 centimeters. So, and they also say that the diameter is 5 centimeter. So, when you have the diameter as 5 millimeters, sorry, not centimeter, millimeters, this implies that your radius should be half of it, right? So, 5 by 2 millimeters, or you can directly say it is 2.5, okay, millimeter. Okay, now, so here just see this height of the hemisphere would be the radius, right? Always remember the height of the, I write it here, note back, height of hemisphere, okay, HS, hemisphere will be equal to the radius of the hemisphere, okay. It is always this. So hemisphere, okay. So using this, what I say is, this portion, this is the height of the capsule, and this side also it is the height of the capsule. So this is 2.5 and 2.5 here. So the length of the cylinder, therefore the length, or you call it height, right? Height of the cylinder will be equal to, from the total 14 millimeters. Now, oh, here it is. Oh, this is millimeters, okay. I have written it as centimeter everywhere. So this is millimeters, just change it to millimeters. Okay. So this is also millimeter, okay. Now, from the 14 millimeters, you have to take away 2.5 on both ends, right? Because that is the height of the hemisphere. So we don't need that. For cylinder, it is just 14 take away 5, that is 9, okay. 9 millimeters, okay. Now, how do you find the surface area? Now, surface area of solid is equal to, this is easy, solid is equal to the CSA of the cylinder, right? The curved surface area of the cylinder. So that will be the middle portion of cylinder plus, so this is this portion, okay, this middle portion. You have two curved surface area of the hemisphere on both ends. So that is 2 times CSA of hemisphere, okay, because you have two hemispheres, right? CSA of a cylinder is 2 pi RH, okay. The CSA, curved surface area of a cylinder, is 2 pi RH plus twice the CSA of the hemisphere. We know it is 2 pi r square, right? So I would just expand and write this is 22/7 for pi, and my r is 5/2, and my h is the cylinder's height, right? So that is 9. Okay, this I have to do separately. This is for CSA of cylinder, and here it is twice the CSA of hemisphere. CSA of hemisphere is 2 times the pi value is 22/7 times r squared. R squared is 5/2 times 5/2, right? So you can simplify this. You can cut the 2 here, and here too you can cut these two and this one, and after doing the calculation you get 220 millimeter square. Okay, or you can also say square millimeters. Here is another question. From a solid cylinder whose height is 2.4 centimeters and diameter 1.4 centimeter, a conical cavity of the same height and same diameter, okay, note that the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest square centimeter. Okay, note this also. Okay, you have a cylinder and you find a cone that has been hollowed out inside. Okay, so you have cut that portion and taken. So you need to find the total surface area. So just imagine the total surface area would be this curved surface area of the cylinder, and you have the base for the cylinder, right? And inside it will be like this shape. This shape is the conical curved surface area of the conical cone, right? Conical cavity which has been hollowed out. Understood? I repeat, you have a cylinder. From that you have hollowed out a conical cavity. Okay, so you have taken it out. You have cut that and you have taken it out. So what will be the surface area of the remaining solid? The remaining solid would be the curved surface area of the cylinder and its base. Okay, to that you need to add inside. It will be like a cone, right? It is conical shape because that much is hollowed out. So that conical shape, the curved surface area of the conical shape you have to add. There is no need for the top because the top is open, right? We have cut and you have taken it out. So there is no need for the top of the cylinder. Understood? So here they have given you the height of the cylinder as 2.4. The height of the cylinder and the cone is the same. Okay, the cone's height is also 2.4. And the radius of the cylinder, the diameter is given. The diameter is, okay, let me take down the diameter. Diameter is given as 1.4 centimeters. So that implies your radius is equal to half of it. So that is 0.7 centimeters. Okay. And for both the height is given as 2.4 centimeters. So this is simple. Only thing is you should understand how when they ask you for the total surface area, which all you should take. Okay, so now I would write the surface area. The total surface area of the solid is equal to I said the curved surface area of the cylinder, right? Of the cylinder, and then you will need to add the base of the cylinder, right? So add base area of the cylinder. Then inside it will be curved surface area of cone. Okay, so if you add all this you get the answer. So let me write the formula. The curved surface area of the cylinder is 2 pi RH, right? You know what is R, you know what is H. So next, base area is, it is circular shape. So that's pi R square plus curved surface area of the cone is pi RL, okay, where your L is the slant height. But we don't know what the L is. So this is what is L, right? And this portion you know it is 0.7. So since it is a right angle here, it is like using the Pythagorean formula. Let me find out the slant height. So slant height is L. So L squared will be equal to, since that is the hypotenuse square, it will be like height square plus the radius square. Okay. So here your height square is 2.4 square plus the radius is 0.7 square. So your L is equal to square root of 2.4 square is 5.76, okay, plus 0.47 the whole square is 0.49, right? So when you add them up, you get square root of 6.25. So the square root of 6.25 is going to be 2.5. Okay. So your slant height you have got, it is 2.5 centimeter. Use this. Okay. Use this also. Now I am going to put the values here. So it is 2 times 22 over 7 times R is 0.7, right? 0.7 times height is 2.4. This is for the cylinder, right? Curved surface area of the cylinder. Then you will have to add the base area of the cylinder. So that's 22 over 7 times pi. This is 22 over 7 and it's R square. So that is 0.7 times 0.7. Okay. Plus you need to add the curved surface area of the thing, that is pi RL. Pi is 22 over 7 and your R is 0.7 times your L is 2.5. Okay. So just do the calculation. So that is going to be, this one will give you 10.56 plus this area is going to be 1.54. To this you can add the CSA of the cone, which is 5.5. Okay. So this will give you 17.6 centimeters square. And in the question they have asked you to round it off to the nearest centimeters, square centimeters. So I would say therefore TSA of the solid is equal to 18 centimeters square. Okay, I just round it off. So this is all. This is how you find the surface area of the combined figures. Okay, combination of solids. Hope this video was useful to you. See you in my next video. Till then, bye.